Hi there. Welcome to another video on math problem solving. Here's today's problem. We have a rectangular area which is of the size 3 by 7, 7 in length, 3 in breadth. And there are three types of tiles, a 2 by 2 square, a 1 by 4 rectangle, or a 1 by 1 square. What is the minimum possible number of 1 by 1 tiles used so that the entire 3 by 7 rectangle is completely covered? Now, the reason I chose this problem and the reason I like this is it's an application based problem. So there is no formula, there is no preparation for this. This is actually doing trial and error. This is actually thinking of patterns. This is actually thinking of possibilities. That's the only way you can solve this problem. Now, since the area that you need to overlap is only 21 squares, you might get away just trying to fit in these, trial and error and everything can kind of help you out. But if this problem were to change into a 30 by 70 rectangle, right? In other words, 2100 squares, arriving at this might be a little bit tougher, right? But you can still figure out the patterns which will help you at least come at the answer. Okay, so that's exactly what I want to focus on today. So if you want, you can pause the video here, try to solve it. The 5 solutions given or the answer choices given in the problem are 1, 2, 3, 4, 5. So let's narrow that down as well. So the answer is going to be one of these 5 numbers, and let's see if you can arrive at the answer. So please go through your process of productive struggle, pause this video, take about 5 to 10 minutes to try and solve this and see if you can get the answer right. All right, welcome back. I hope you went through the grind of trying to solve this. If you did, very, very good for you. Okay, now let's think about how to solve this problem, right? The first thing I would look at is the number of total tiles that needs to be covered, which is 21. 3 times 7 is 21. So we have a total of 21 tiles that needs to be covered. Now let's name the square tile to be type A, the rectangle to be B, and the smaller square 1 by 1 to be C. The thing about using tile type A or B is that it's always going to be a multiple of 4. So even if you were to fit in all 5 A's or all 5 B's or a combination of A and B so that there are 5 of those used, maybe 3 A's and 2 B's, you would still be always left with 1 square free because 20 is the maximum you can reach. You would be left with 1 square, right? So that's the minimum that you're looking at if you're able to fit 5 of them. So this itself will help you kind of remove all the other possibilities that it cannot be 3, 2, or 4. The answer has to be either 1 or 5. Why is that? Because if there were 2 1 by 1 tiles, then the remaining would be 19. And 19 is not divisible by 4. Or for that matter, if it were 3 1 by 1s, then you would be left with 18, and therefore that's also not divisible by 4. And if you were to have 4 1 by 4, then it will be 17 remaining tiles, and that also will not allow you. So these 3 can be eliminated right away. The answer needs to be 1 of 5, one of these. So it's 1 tile when you're able to fit 5 of these, and it's 5 tiles when you're able to fit 4 of these. So this is where a bit of trial and error is necessary. For example, let's see if you can fit it only with type A. So this is the best I can hope for. I can fit another one. I can fit another one. So I can think of 3 here. And the best I can do with type B is to hold this. So therefore, I'd still be left with this odd L-shaped region that needs to be filled with type C. And therefore, it has to be 5. But what are the other ways I can do? I can use type B first. So this is B, this is B, and this is B. And what I'd be left with is another type A. And again, I'd be left with 5 possible ways in which I can fit it in. You could say, okay, let me try a completely different way. I could try this. I could try this. I could try this. So I'd be left with 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, 9 possible squares for which I could do one by one. But this is a very inefficient way of fitting it in, because all you need to do is push this guy up and you'll be able to fit something with type B. So if you were to look for an efficient solution, you'd always try and see A and B together and minimize that number of squares that you need. But while this is inefficient, these two are not. These two are definitely efficient solutions where you can leave only 5. So the constraint of the shape ensures that you'll never be able to fit 5 of them together. The best you can do is 4, which is like 3 A's and 1 B, or 3 B's and 1 A, but not all of them together. And that's the reason the answer has to be 5. 1 by 1 squares is at the minimum necessary to fit into this 21. Now, what happens if you think of a larger size? So, for example, if you had a 30 by 70 or a 30 by 7. So that's when you start thinking in terms of patterns, in terms of divisibility, and see if you can at least work at eliminating few of the options and then selecting what is left. I hope you found this interesting, insightful, and something that you would like to apply in your problem solving. If so, please do like, share, and subscribe, and I will see you in the next one.